We're waiting to be online. Says we're offline, says we're starting. And we've got audio, good. So there's just going to be more of the same as the last stream. Because this, if you didn't see it, is the headlight elevator to my work van. It's a Nissan Serena from 1999. And whoever used to own this particular vehicle just didn't ever use these, and it's illegal to drive a van without electric headlight elevators if the vehicle was fitted with them. So I've got to fix these, and in the previous stream we had this apart. We realized that the electric motor was just jammed full of rust and crap. So we fixed that. I let it sit overnight in some oil and WD-40, and I rather rudely just reassembled and tested that without you guys ever knowing about it, and it worked very well. So this is the other one. We're going to be doing the same thing all over again. And perhaps we can find out if we can do it a bit more efficiently now that we know what tools are required. Right. I have no idea what these actually cost if you want to buy them, even new or used. Probably a shit ton, since they all fail the same way. This thing is underexposed. There we go. So yeah, I had a bit of an issue reassembling the last one, since I'm going to zoom you guys in. Try it anyway. Since this is just melted plastic studs holding the PCB in, it's basically impossible to take out non-destructively. So perhaps we can use hot air to just soften that up, since we've obviously melted them to get them in place to begin with. Let's give that a go. We're probably not going to do more harm than good, but I want to get rid of this gasket so we don't accidentally burn that. So we're going to need a knife, there we go, knife. People are showing up in the chat. Hello. So let's see if we can get rid of this gasket somewhat painlessly. That's a rather thick gasket, actually. A very thick gasket, actually, but there we go. That ought to come. Very thick, but it's gone rather hard, so yeah, not in good shape. So that's the gasket out of the way. Let's just get some hot air going. I have a tiny nozzle on that, so let's do like the pros and plug the hot air station in before we try and use it. That usually makes things work out a bit better. Let's do like, I don't know, 250C. Let's do 280. 280C on the Aten horrible cheapo hot air thingy. Ugh. How can these things fill up with so much garbage? Yeah, that's heated up. Let's see if we can just gently melt that plastic. Now we probably don't want to melt that axle, which is most likely made out of the same kind of material, so I'm just going to put some aluminium foil over that, just to spare us the effort of having to rebuild that due to just turning it into a molten piece of garbage, like so. To refit the board in the other one, I just used some pool noodle it worked rather well, but I don't know how long that's going to last. So this is a much better way of doing it. I have no idea at what temperature this plastic is going to want to melt. 250C might be a bit on the cool end. This stuff is smelly. It is turning. Something's happening. It seems to be burning more than melting. It seems to be getting somewhat soft. And we really don't want to damage the outer case here, because that's just gonna cue moisture ingress even worse than these have had. Yeah, that worked. So we have 2 more of these. This is going to make reassembly a lot easier, since we can just melt it back in place. This PCB does not like the heat. It's turning all horrible. Okay, that's the second one. We're not going to be able to just slide the third one out, since we have a bunch of stuff poking through the board, so we'll have to heat that up as well. It's actually getting a lot better than I did expect. I was just expecting the plastic to basically just burn instantly and go to shit. I'm also trying to find anything that the PCB doesn't like the temperature. You probably can't make it out quite well on camera, but the PCB is turning all kinds of colors from doing this, and PCBs can usually handle 200C just fine. Pop. Okay. Out you come. And I do believe we have an even worse motor in this one. Man, that's horrifying. Ugh. What's the chat say? Not a lot. Right, so I'm going to assume we have the same issue on this one, where if we put power on the motor, it's just gonna draw a bit of current and not do anything. The chat says, more motor herpes. Yes, indeed. This really is herpes. It looks so horrifying. Completely horrifying. Oh wow, these plastic shreds did not enjoy getting soaked in oil in the last stream. They're turning into some form of concrete. Right, power's on. This one isn't drawing any current at all. So that probably just means it's oxidized on the rotor and brushes. So I don't think it's ruined any more than the other one. I just think it's gonna need a bit of persuasion to get going. So what was the trick to getting this thick rod out? Man, I did something special. Oh yeah, I squeezed the case in the vise. Maybe we can just squeeze it in my hand like that. Squeeze it because you can see these two plastic clips, they just go slightly further out always squeeze the case, so that's going to minimize the risk of just breaking the plastic unduly. Oh yeah, this works, but it's almost impossible to achieve enough force to actually get the Headlight. Now we're going to have to use the vise, we can't get around that. Ugh. In you go. How much dare we squeeze this? That much. That looks fine. So let's just poke that. Let's get that as far into that end as possible. Pull that and yay! Pop. Beautiful. So I'm going to put that on a piece of paper on the side. We don't need it for the time being, we just need our horrifying motor. Chat says good evening. Good evening, chat. Welcome to more Headlight Salvati shenanigans. Well, if you look at this, you can really see it's been sitting in the same exact spot for a very long time. Like the grease has turned a different color there. Okay. Let's just try and pop this out. Is this going to be stuck in here? Ah, there we go. Yuck. Yuck. Disgusting. So let's see if this is well and truly stuck where I can twist the entire motor by just grabbing the axle. So is that... Oh wow, that's properly stuck actually. Are we going to be able to unseize this at all? Yeah. That's not good. The other one unseized rather easily. This one is not. Yuck. Ugh. Oh, okay. It's starting to turn, making horrible grinding noises. Oh, just listen to that. That's a motor in pain, but at least now it turns somewhat. So if we put some power on this, I'm hoping it's gonna do things. So power comes there. Prepare for screaming. No? It's not drawing any current. Oh? Oh? Yeah, it's occasionally making the amp meter jump. Come on. Come on. Okay, this is going to need a bit of love, but it is trying to turn, so we know that the windings aren't shot, and that's all we care about. That means this thing is worth trying to clean up and restore. If this wouldn't have drawn any current at all, if the amp meter wouldn't have moved, then yeah, that would have been just a lost cause, and I'd have to use another motor because it would be destroyed. Ugh. This is so horrible. Now that's a skid mark. Ugh. Shish. Yuck. Yuck. There we go. So let's just brush this thing out and ugh. Oh, there's like dust rising up from this. It's horrifying. Oh, there's metal underneath there somewhere. Someone says they think some WD-40 will do the trick. Well, we have a mixture of gearbox oil and WD-40 left from last night, so I'm going to submerge the motor in this overnight again, just to allow it to kind of soak into the bearings and the entire assembly pretty much. The other motor turned out really rather nice. It would have had by far sufficient torque to drive everything. I haven't had a chance to test it in an actual headlight because I just have a spare parts van sitting around for testing, and I'm not reassembling the entire headlight assembly just to test these out, but I have it sure that the actual elevators do work. Man, this is so thick. Can we just like scratch this off with a knife? I think we might be able to scratch this off with a knife, if I have a knife. I have a knife. Ugh. Yuck. Stay in focus. Yeah, this is a quicker way of doing it. Like scratching a lottery ticket. Ugh. This is... man. It's amazing that these turn at all given the state of the things, but I suppose the metal case has taken most of the brunt and just turned into iron oxide. I'm just going to vacuum that up. It's just going to go everywhere if I try to brush it. Always have a vacuum cleaner handy. Back to the grinding. Ugh. There's not a lot to comment on about this, really. This is just ugly work. We're going to have to use the knife for that. It's just such a thick layer everywhere. The other motor just had, like, herpes, as someone so eloquently put it. This one's got cholera. No, not cholera. What's that thing where your arms fall off? This one's got leprosy. Where it's just kind of falling apart completely. Ugh. I just look at the amount. Jeez. I'm surprised there's any metal at all underneath there. Like, so much dirt. Okay. Well, that starts to get somewhere. As long as we can get rid of most of the bad stuff, this is going to be fine to just dunk in the oil WD-40 bath. I'm still going to have to blow it out with a compressed air though. Just to kind of get some of the dust out of the insides, because given the amount of material that's coming off of this, a lot of it's going to have to end up inside, and that's not going to be good. Someone says, did they use a cadmium plating on these? I have no idea. I mean, if you know what a cadmium plating is, you can probably tell better than I can. Okay, this is starting to turn into something somewhat presentable. Sandpaper, the stream. Someone says it's cadmium plated if it's pre-90s. This is not pre-90s, this is 1999. But yeah, now I'm going to go and blow this out with compressed air. So the mute function of this microphone doesn't work anymore for some reason, so you're going to have to hold your ears. Just be warned. So, horrible noises in 3, 2, 1. Okay, that's it for the compressed air. Now it makes an even better noise. That's lovely. So let's see if we can make this thing scream by putting some current through it, now that it's been exercised a bit. It's trying. It's really trying. Let's get some contact cleaner in there, just normal PRF 778. That's not for bearings, it's just for over brushes and commutator. Oh, still no screaming. Come on, it really wants to go. Hey, it's going. Sounds like some kind of electric locomotive. Oh, this poor thing is drawing 5 watts. 5 watts of pure pain. But at least it turns. Wow, that's right, it's so warm. Oh, the poor thing. It started spewing rust out of the rear bushing. Just look at all that gunk coming out. Whoa. Nope, no rust on the water. Now I'm thinking perhaps if this contact clean has some very lightweight oil in it, if we just squirt some of the top bushing there, it's probably going to penetrate reasonably well. Yeah, look at that, it stopped screaming right away. And now it's turning quite well. So now it's probably going to turn quite decently. So let's turn down the voltage a bit and spin it a bit more. Hey, look at that. Beautiful. It's turning really well now. Let's just get down to like 2 volts. Yeah, that's turning at 1.5 volts. A couple of spots on the commutator seem to be in bad nick still, because it can stop in certain spots and not get going again, while other spots are fine. So that's not really good. It's not clean inside yet, but we can probably shove some more of this lightweight oil in there just to let it flow through. You can't use the PRF 778 for actually lubing stuff up other than potentiometers. Not even potentiometers, because the oil is so lightweight, it's just it just runs through and disappears. If you use contact cleaner on like the axle of a potentiometer, it's just going to turn into the garbage because it's too light. You don't get any resistance. But it's good for cleaning stuff up, out, just flushing things. I think this is probably the lightest weight oil I have in the workshop. Yeah, it's turning out quite well, I do think. We have achieved spinning. And now when it stops, it's actually drawing current, which is good. There's a spot where it's not drawing any. Like if it slowly turns, we're probably going to come upon, yeah, there's a few spots where it'll just stop drawing any current at all, because there's dirt on the commutator bars. But really this thing could be doing so much worse. So it's drawing current, drawing current, drawing current, but it stops drawing current. There's just a couple of really specific spots. And we could probably do with just putting some pure alcohol in there. Pure alcohol works wonders on dirty commutators, turning the voltage up slightly so it gets to turn a bit quicker. Let's see if we can manage to find the dead spot again. Yeah, there's still a dead spot there. One single dead spot. That's not good, because if it ends up on that spot while in service, it's obviously not going to work. And it's not going to work until we go out and bang the headlight hard enough. That's no good. Oh well. Oh well. Yeah. I think we really can't ask for perfect here. I really just want to dunk this in the oil bath now, so that we can get some heavier weight oil in the bearings. So that they'll get properly lubed up. But running this at various voltages from 1.5 up to a lot, it's really acting quite well. And once we get above like 1.5 volts, it's turning quite smoothly. The dead spot seems to be less of an issue at higher voltages. But it's still there. You can make... Come on. If we get it just right, we can make this thing not go. But it's really getting a bit hard. Someone in chat is asking, what function does this perform in the headlight? It angles the reflector up and down, so that depending on the load you have in the back of a vehicle, you can adjust the angle of the headlight so you don't blind people. Someone asks, raising the headlights? What car? It's this goes in my Nissan Vanette cargo work van. So it is a van rather than a car. But yeah, let's just submerge this and work through the PCB and make sure that's in good nick. This plastic container does not like this oil. I think it's kind of starting to dissolve. Dunk. Let's just shake that up a bit. Let's add just a little more oil in there. Because the other motor absorbed quite a bit of it. There we go. Drip. Drippy, drippy, drip. And this is 7590 gearbox oil. I'm not using that for any particular purpose, it's just the first one that I found. And I like using a rather heavyweight oil on these things because if you use a really lightweight oil, my experience is that it tends to just disappear. It runs out of the bushings and doesn't last very long. Whereas heavier weight oils, they become more grease-like, obviously. They tend to stick around for longer. So we'll just leave this running at like a really low voltage in this for a while. 2 volts. And put it to the side while we take a look at the PCB. Someone says 300ZX. I am confused. Nissan has made more than one vehicle. The Nissan Vanette is assuredly not a 300ZX. Someone asks if I'm politically active, and not quite. But whenever there's like EU stuff going on that's trying to destroy the internet, I usually send emails to EU people from Finland because, yeah, I like the internet. You should all go protest Article 13, by the way. Look up if there's any protests in your area. Because that's, yeah, Article 13 is a bad thing. A bad thing for everyone, made up by people who don't understand the internet. Someone asks, do you like the EU or not? I like certain aspects of the EU, and I dislike other aspects of the EU. I don't think it's sane to just say I like the EU or I don't like the EU. This is dirty and horrible. Man, this is really dirty and horrible. This one's had a lot more trash come into it than the other one. What on earth is that goo? Has someone been soldering in this thing? No, that must be oil from the axle or something. So let's clean that up using isopropyl alcohol. Grease be gone. We don't need grease on our gold-plated thing. Someone says in chat, you can't believe how Paris and Berlin and Vienna look today. It's unbelievable how negative everything changed. I don't think it makes sense. I'm assuming that the person saying that is saying the EU caused all this negative stuff to happen. I think that's just looking for a boogeyman. The EU is involved in a lot of things that concern many European countries. Obviously, that's the point. But the refugee crisis would have happened regardless of whether or not the EU was there or not. Like, the EU is not the entity that's causing refugees to try and flood Europe. That's refugees doing that for their own political reasons. So yeah, don't look for boogeymen. That's just a cheap out, in my humble opinion. There we go, that's our PCB. So this gold-plated thing has really started to get coated with some dirt, so we're going to start out by just cleaning that out a bit better. Someone in chat is talking about Israel. Do you really have to go there? Can we not like have a place on the internet where we don't talk about Israel? Are you like some maggot type person from like Paul or something? I don't know. This stuff is not coming loose at all. Perhaps it's just wear and tear. Let's have a closer look. Now this thing is coated in what seems to be some kind of oxide layer. But it's so thin, I'm going to wager it's not going to be a problem. Like if we measure resistance across there, I don't think that's going to be non-conductive. I think that's going to conduct electricity just well. So since the area of the PCB is gold-plated, I don't think it makes sense to, for instance, try and sandpaper the oxide away. Well, that's actually not conducting very well. I've placed my probes very lightly on there. It works fine. Screw you, auto ranging. So if I probe very lightly there, it's fine, it's fine. It's fine, it's fine, it's not fine. Yeah, that's going to be a problem. I'm surprised that this is going to be a problem. Because it's... the dark part of the pad there really doesn't conduct at all. You really have to stab through the top oxide layer to get any kind of connection. So we are going to have to sandpaper that. I did not expect we'd have to do that, but science prevails. Two-facing grid sandpaper. Let's just give this a very gentle rubbing. We really don't want to rub through the gold plating, because that's just going to make it worse in every conceivable way. We just want to get rid of the dirt. Yeah, it's coming off. Perhaps if we put some alcohol on there, it's going to help carry the crap away. Now that starts to turn. Is that just becoming reflective and nice, or is it becoming dark and horrible? It's hard to tell. Let's just check with the probes again. Like, I'm barely applying any pressure here. Now that seems fine. Like, I'm just barely allowing the probe, the black probe, to touch there. So just to be sure that we're not piercing through the dirt, but rather we're riding atop any dirt. So that looks pretty good. I think that's going to be a non-issue now. We still need to get to the small pad as well, because that's got the same issue. So some alcohol on there and give it a gentle rubbing. I'm using very, very gentle force here. It's pretty much the weight of a sandpaper being applied. Well, there's some dirt on that end of that. That was a mistake. Fresh Q-tip. I think that one's going to require a bit more work still. Yep, that's going to require more work. Scratchy, scratchy, scratchy. This dirt really seems to be quite thick on this one. How's that turned out? It's difficult to gauge when you're through because it goes from black to highly reflective. Now that's starting to look. That's okay. I can just very gently slide my probes around there, they're making good contact. This one I think is going to be okay. Yeah. Or is that not okay? Very slightly dodgy, so let's just give it a very gentle little rubbity dub. Just to get rid of any possible issues. These pads are what determines when the motor stops turning, so if these are dirty, you're not going to have the ability to, rather the little chip on this board is not going to know when the headlight is properly adjusted. So it's just going to keep on turning until it reaches a pad that connects or until the internal timer runs out, but that's looking fine now. And is this one okay? No, this one's not okay. The pads in the middle seem fine, yeah, but this one also needs a bit of a rub. What an odd issue. Contaminants coating a gold-plated part. That's weird. I'm not sure I've seen that before on something that's not horribly water damaged. This is water damaged, but it's just rather mildly so. That's right, that's going to be good. Let's just gently touch that. Nope. On it, there we go. Yeah, I think that's going to be good. Right, so that's that issue taken care of. I'm going to switch directions of the motor, turning a bit oil just to help the oil enter all the little different places. So that pretty much sums it up for that part of the PCB. Just going to rub this harshly to get rid of any dirt. There was quite a bit of dirt on there. Now that's now gone. So we're just going to flux and reflow most of the solder joints on there. This flux syringe is going bad. I'm surprised. This is like maybe a year old flux. I don't know, these actually went bad. Expiry date 31st of the 8th, 2018, so yeah, this is expired. But I'm sure it's fine. Doesn't say when it's manufactured though. I'll just flux all kinds of things and reflow them just in case the moisture's done them a disservice. Let's use a slightly smaller tip on this soldering iron. If I can find my rubber solder tip removal tool. I just touched that tip. Where? My glove saved me a lot of pain there. I just shoved my thumb up against the solder tip and it didn't penetrate the thumb and I'm not in pain. Phew. Thank goodness for rubber gloves. So let's use the what's this? The LF, I think this is called the LF-D8 tip. It's like or maybe it's the D16. Yeah, this is the D16. It's 1.6 mil wide. There's a D08 as well, which is 0.8 mil, but I don't have. I know this is the D08 actually, because I think this is the D16. That's the D08, yeah, because it's about twice as wide. When I get my new toy, I'm going to have to get some more precision tips for this iron. Because I just have, I think this is pretty much the smallest one I have. So, yeah, let's just reflow this. This tip needs more heat. At some point I am going to construct a solder tip holder for these 2901 tips, because all of these tips, since the heater is integrated into each tip, every tip has its own temperature adjustment coefficient. Like if 350 on the tip we removed is not the same as 350 on this tip. This one requires quite a bit more heat to actually reach the same temperature, just because the feedback circuit is different. So for an actual 350 on this, I need to set the station to like 410 or something. It's easy to calibrate because you can just check the temp of a tip when you get it, and it doesn't quite change over time at all. But you need to adjust the temp every time you change tips, or you're just going to be sad. I would wager, if you have like one of the Heiko stations with the same kind of tip technology, one of the things you're probably paying for is the manufacturing tolerances of those tips, not requiring you to adjust the temperature. Because it is a bit of a bother, especially if you don't know about it. Like it doesn't say anywhere in the manual that's the case, because it's not supposed to be the case. It's just what happens when you have sloppy Chinese manufacturing. This solder does not get along with this board. It's just so oxidized. I'm glad we don't have my new toy yet, because then you'd see how bad these solder joints actually are. In cases like this, it's pretty much always better to reflow the solder joints than to not reflow them, because you're not going to, in any way, cause a worse connection. But it's going to look like shit if you don't bother cleaning all the oxide up beforehand, as I am not bothering to do right now. Could be that the expired flux is also not working, of course, as well as it should, but I don't think so. I think it's just too much oxide on these joints. Someone asks, is it 6040 lead solder? I think, no, it's 6337. So it's better than 6040. .6337 is so much nicer to work with, since it solidifies much quicker. It has a much narrower, like, plastic temperature range. So if you're mechanically holding two things together with 6337, you're not going to run into the issue where it's almost solidified when you move a little and it kind of breaks half of a joint. 6337, it pretty much solidifies all at once every time, making handheld work a lot easier. But yeah, this is so incredibly ugly, but it's going to work just fine, so I don't care. It's just for my own use anyway. No obvious huge issues on the other side of the board. But I'm gonna brush it off slightly because we have rust everywhere. So yeah, it's ugly and oxidized on the top side, but it's a plated through board. It's gonna work. It's gonna work just fine. It's gonna work just fine. And these are oxidized and horrible, but yeah, these are difficult to get at. So I'm just gonna use some of the 778 when I install this, and just soak it and wiggle the board up and down a few times. I'm not going to do that right now because it's this board is really annoying to actually get out of here if you just put just the board on there. So we need to have the motor ready and the entire assembly reassembled to get to that connector. I learned that the hard way with the other one. So let's also clean this up. Get rid of some of the horrible old grease. Get rid of all of the horrible rust. Ugh. Rust and corroded metal. Yuck. Wipey, wipey. A bit of isopropyl alcohol makes everything easier. Oh yeah, let's not forget these two electrical contacts, which help the chip determine the position of the headlights. We want to clean those up as well, just with some isopropyl alcohol on a Q-tip to get rid of the old grease which is on them, which has turned hard and it's not going to be very conducive to good contact. So there we go, squeaky clean. I can use the same Q-tip to just kind of wipe some horrible old grease out of these. There we go. That's good enough for me. Good enough for me. This has a bunch of garbage on it, so that goes away. And this turns really poorly. This feels horrible. This mechanical part is just a manual adjustment for the headlight. You pre-adjust on this, then you use the electrical adjustments. I'm not sure how we're gonna actually get at this though. Like, this is the electrical adjustment, that moves the white or the uncoloured plastic part in and out. Now there we have a thread for the manual adjustment, so we can just put a dab of grease on there and it's probably going to be fine. Well, that's good. There's some lightweight oil on there. Oh no, that's water. There's water in this. So now we've figured out this is where the water is coming in. This is where the water is coming in. So we can probably stop some water coming in by just putting some lightweight oil on there and then just shoving it full of grease, like big fat automotive grease. It doesn't quite matter if some water gets trapped in there, since it's just plastic. We just want to stop new water coming all the way into the electromechanical assembly. So this is just normal CRC brand moss grease, and we'll do that and use a toothpick to kind of poke it inside between the little openings in the plastic there. And we'll just turn this top to bottom a few times. Keep poking grease in there. It's turning a lot easier already. The motor just stopped turning. Let's turn up the voltage. There we go. Pokey, 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 pokey. This is exciting. And exercise it, and poke some more grease in there, and exercise it, and poke some more grease in there. We can probably get some more grease in there by just kind of poking it down. There's a slot going quite deep here, so I know it doesn't go deep at all. Rip my dreams. Maybe it goes somewhat deep if we turn it all the way down. Pokey pokey, grease everywhere. To quote Adam Savage, I think you can never have too much grease. You can never have too much grease. Now we have slots on the other side as well, which we can put grease into. Oh, this is turning better than it did when we started, so that's good. I don't really care if this gets contaminated with stuff and dead bugs and sand and crap once we're done, because this is still just a manual adjustment. this black dildo doesn't turn by the electrical motor, so you can use as much force as you want to turn this. It's more important that the black cog here turns freely, because that's actually turned by the electrical motor. And since we've been shoving grease all over, we are actually also lubing that up. There's a mysterious fluid coming out. I think that's water. I think my grease is just kind of sucking water out of the assembly, so I'm going to wipe that off and then we'll be good. I don't think that's the lightweight oil I put in, because I barely put any of it. Yeah, that's water. Oh well. I guess all the in and out action is making it wet. Ha. Dirty jokes. I could probably just put this on a kind of warm thing overnight and most of the water is going to evaporate, so I don't think we need to pay too much attention to that. It's good enough. It's good enough. And I think that's pretty much as far as we're going to get today, because to get any further we need to have the motor done, and I really wanted to allow that to soak overnight, just to get as much oil into the bushings as we possibly can. So we are reaching the end of the stream. We've refurbished our PCB, we've gotten our motor turning. Look at that beautiful little thing. It's no longer brown. So I think I'm going to have to thank you guys for watching. And make sure you enjoy yourselves, and I'll see you around soon enough. Bye.